Hello friends, welcome to Analysis of Machine Elements. Today we will be studying the concept of pure bending. Up till now we have been studying different types of members under axial loading. This type of loading is either tensile or compressive in nature. However, when any beam is subjected to transverse loads or moments, the beam bends and a very different type of stress is seen in the cross section. Here we see a beam which is subjected to two bending moments. This will cause the beam to bend and create stresses within a cross section in a very unique way. The curvature of the beam will be uniform if the load applied is in the form of pure moments. Practically, beams are seen everywhere, right from big buildings to different machine parts which we use in everyday life. Transverse loads and moments cause the beams to bend, and it is a must to understand how this impacts on the stresses within the cross section of the beam. Now let us try to understand the effects of transverse loading on a beam. Here we have a simply supported beam and it has got a centric load in the center. After the load acts on the beam, it is but natural that the beam will bend in the following way. Under the action of the point load, the beam gets a sag as shown in the diagram. When the beam bends in the following way, stresses are developed in the cross section. Now, there are different ways in which the beam can bend. The beam can bend because of pure bending also. The pure bending can be understood from the following diagram. If a beam is given a pure moment by attaching two bars at the end and giving the load as shown. The load at this side will create a moment in the following way, and the load at this side will also create a bending moment. Because of these two bending moments, the beam also bends and bending stresses are created inside the cross section of the beam. These bending stresses will be evaluated in this unit. Bending is also produced by transverse loaded. However, along with bending, it also causes shear. So that will be studied in the following unit. So currently we will focus only on pure bending, which creates only bending stresses. The transverse loads create bending stresses and shear stresses, and that will be covered in the next unit. Coming back to the slides, this chapter will be devoted to analysis of prismatic members, basically they are beams, subjected to equal and opposite couples M and M dash, acting in the same longitudinal plane, which is seen in this diagram. Such members are said to be in pure bending, and the members will be assumed to possess plane of symmetry, and the couples M and M dash will be acting in that plane. Now these are some examples of pure bending again. Here we see a beam in which two loads of 80 pounds are acting at the end, and the reactions are also symmetric and equal to 80 pounds each. Because the loads are same, in the central part CD, only a moment will act, and that moment would be because of the couple generated because of this 80 pounds and the distance between them. So in the central area, only pure bending will act. An example of this can be seen in the weight lifter. So the weights that are being lifted, these are the forces, the hands are the reactions, and the central part of the beam is in pure bending. As we discussed earlier, this is called transverse loading, where the load is perpendicular to the axis of the beam. Because of this load, there is surely a bending moment created, but also a vertical shear is also created to nullify the acting vertical load. Therefore, this type of loading is called transverse loading and creates shear as well as a bending moment. This will be studied in the third unit.